You can learn a lot while thinking about wrong answers from exams. One example. Here is a question of a recent exam. We have a starting material, cyclohexanone, and we have catalytic amounts of an acid, abbreviated as HA. So, heating it up, what is the correct answer one was waiting for? Well, this reaction is then aldol addition reaction and followed by aldol condensation. So, one answer we received was discussing the mechanism. The carbonyl is protonated. We have this reactive intermediate. Mesomeric structures, especially this one, shows that we have an increased polarization, positive polarization of that carbon. This increases its electrophilicity. Well, the correct mechanism leading here to aldol addition and aldol condensation is the formation of the enol tautomer, and the enol tautomer then will attack at that carbonyl group. Well, here one student had the idea, well, it could attack this cyclohexanone, could attack here at such a position with the free electron pairs of the oxygen. Then we get to this reactive intermediate. Well, next step could be, again, here we have an electrophilic center. Why not a second time attacked by cyclohexanone? Then we are here, and it could go on, and this is then a polymerization. Well, it's the wrong answer to this question here, but thinking about, is it possible that a carbonyl compound polymerizes under the influence of an acid? Yes, there is a very prominent example, and I have it here in my hands. This is polyoxymethylene, abbreviated as POM. This, clamps from the lab are made of that industrial polymer. The industrial polymer itself is colorless. Here there are some dyes in there. And how is it made? Well, you start either from formaldehyde, but more practical because easy to handle, from its cyclic trimer, the trioxane. If you treat it with a little bit of a proton source, or even better, a Lewis acid like BF3 etherate, then one of the fastest polymerizations we know will happen, and this is how the polymer looks like as a structure. We have an oxygen, CH2 group, oxygen, methylene, and so on. This is POM, polyoxymethylene. It happens with formaldehyde or trioxane readily, but it doesn't occur with cyclohexanone. So we should think about, why does that readily happen here but not there? Well, okay, it's an equilibrium. It can decompose, and it will decompose much easier here with the cyclohexanone units as there. Why is this the case? Well, as you see, this with the cyclohexane moieties here is sterically far more crowded than the POM case, and more important, this cation here is far more stable than the corresponding cation of the formaldehyde, because here we have an additional stabilization by the inductive effects of those two neighboring carbons. These are more efficient than the inductive effect of the neighboring hydrogen. So it decomposes far more easily back to cyclohexanone compared to the decomposition to form aldehyde. Thanks for listening.